All right, this is Circles Lesson 2. Let's start with the first three problems where we have to determine the measure of each arc. So if I look at the first one, I see that there's a rectangle within this circle, which means that I have this line congruent to this line. So that means that the arcs congruent to those, or those arcs formed by those two congruent chords, those arcs must be congruent. So this arc must also be 4x, just like his other one. Similarly, this line must be congruent to this line, so therefore I know that those arcs cut by those chords must be congruent, so this arc must be 2x. Now that I have all of those arcs labeled, I know that all of these arcs together must make 360 degrees, so that means that 2x plus 2x plus 4x plus 4x, all of them together must equal 360 because it goes all the way around a circle. So if I add that all up, 2 plus 2 plus 4 plus 4, that's 12x. So I have 12x equals 360. And then if I divide by 12 to get x by itself, I have that x equals 30. So now I know what x is, but that's still not the answer to the question. The question asked me for each of these arc lengths, or arc measures. So if I know that x is 30, I'm going to times 30 times 4, and I'll get the arc measure for here, which would then be 120 degrees. So that's one of my answers, which also is the answer for down here because it has to be congruent. So I know two of the answers is 120. Next, if I plug in 30 for x here, I know that this arc then must be 60 degrees, which means this arc must also be 60 degrees. So I have all my arcs measures, so I'm ready to move on to number 8. Here I have an isosceles triangle, which means this line is congruent to this line. So if I have two congruent lines, I must have two congruent arcs, which means that 7x must be the same as 7x over here. Altogether, 7x and 4x make the entire circle, so that means that all of those arcs added together must equal 360. So if I add those all together, I get 18x must equal 360. And then if I do 360 divided by 18 to get x by itself, I have that x equals 20. So now I know what x is and I can plug it in. If x is 20, I times it by 7 to get 140 degrees for the left and right arc, because again, they're congruent. And if I plugged it in down here, times basically 20 by 4, I'd get that the bottom arc is 80 degrees. You can check to make sure that's true by adding 140 plus 140 plus 80, and that better equal 360, or else you did it wrong. But that works out, that checks out. The last one doesn't have any numbers here. However, I see that I have a diameter, so this arc right here must be 180 degrees. That means this arc down here, the last arc, must also be 180 degrees, and since all of these are congruent, these all I could put as x. In other words, 3 of those x's must add to 180 degrees, so that means x must be 60 degrees. If each of these individual arcs down here was 60, 60 plus 60 plus 60 is 180, plus the other 180 on the top, and I've got my whole 360 for my circle. All right, let's move on. The next one, 10 through 18, we have some information about. First off, I know that AB is equal to CD, and that's 24. So AB is 24. And CD is 24. I'm going to stop right there before I move on because I see that these radii or these radius connect or go through those two congruent chords at a 90-degree angle, which makes me think that these individual pieces must be congruent. In other words, the radius goes through the chord and is a perpendicular bisector. So each of those individual red pieces then must each be half of 24, which is 12. So I know all of these little red pieces are 12. All right, moving on. I also know that the arc from C to Y is 45 degrees. From C to Y out here is 45 degrees. Well, that means that since this is coming from this congruent piece, the arc from Y to D, which is coming from a congruent piece of the chord. This chord is congruent to this chord, so this arc must be congruent to this arc. Similarly, I can bring that across the circle. This chord is congruent to this chord, so that arc from X to B must also be congruent to the other arcs, and same thing for X to A. So now I can answer some of these questions. The length from A to Q is 12. The length from R to C is 12. The length from Q to B is 12. And the length from A to B all the way down is 24. That was given to us in the instructions. That's a funny question. All right, anyways, moving on. The measure from D to Y. Arc DY is 45 degrees. The measure from arc AB, A all the way to B, that must be 90 degrees. The measure from A to X, arc AX, is 45. The measure of arc XB from X to B is 45. And the measure of arc CD from C all the way to D, that's 45 and 45 together, that's 90. Perfect. Let's move on. Next, the hint here is to draw a picture. So let's start with a circle. I know that there's a chord in this circle that's 20 inches long. So it doesn't say where it's at, but I'm going to go ahead and draw it just down here, 20 inches long. I also know that the length from, or the distance from the center of the circle is 24. Remember that we always measure distance using a right angle. So this red line has to meet at a right angle with the blue, and that's 24 inches long. Remember, this red line is not a radius. The red line goes from the center to this blue line, but see this empty space down here? That means that the red does not go all the way through, in other words, doesn't go to the edge of the circle. So the red line, this 24, is not the radius. We need to find the radius, which means we need to do some math here. I would suggest drawing a radius from the center to this end point of the chord. If I find this radius, I will have my answer. So what I see there is a right triangle. If I draw that right triangle again, I basically have this going on. 24 for this line, X for this line, and be careful, this is not 20, it's half of 20. Remember, if I have a right angle here, that means I cut the chord in two equal pieces. This is a perpendicular bisector. So 20 bisected into two equal pieces would be 10. Now I can solve this using Pythagorean theorem. A squared plus B squared equals C squared, where my C has to be my hypotenuse. The hypotenuse of this triangle is X, so I'm going to put X squared for that, and then the A and the B are interchangeable. Now I'm going to go ahead and solve. 24 squared, that gives me 576. 10 squared is 100, and then I have X squared, which I don't know. So I'll add 576 plus 100 to get 676 equals X squared, and I want X, not X squared, so I'll square root both numbers to get the X by itself. That gives me X by itself, or the radius of this circle, is 26 feet long. For the next page, the only information I know for 20 and 25 is that line DG is congruent to line GU. So DG is congruent to line GU. That means this guy right here is congruent to this guy right here. In other words, well, this one's given that it's 3, so this one must be 3 as well. Let's solve some things before we actually start answering some questions. I see a right triangle, so I immediately want to do Pythagorean theorem to find this purple length, which I'm going to call X. I see that triangle, so A squared plus B squared equals C squared. And the C has to be the hypotenuse, so the hypotenuse of that triangle is 5. And we'll say that the B, or the A, is 3, and the B is, I don't know, we'll call him X. So I have 9 squared plus X squared equals 25. I'm sorry, 9, that's what 3 squared, so not 9 squared. There we go. 9 plus X squared equals 25. If I subtract 9 from both sides, I have X squared equals 16, so square rooting gives me X is 4. So the length of that purple line is 4. Well, I know that this guy is a chord who is equidistant from the center, so this entire chord is equal to this entire chord. I also know that I have a right angle, so this chord was cut into two equal pieces, so that means this guy is congruent to this guy, so the bottom half there must also be 4, which means that this guy must also be 4, and this guy must also be 4, okay? Let's go ahead and see if we have our answers to the questions we need. First, it asks for the length from T to U. From T to U, yep, we have that, it's 4. From the length from T to R, well, it's just 4 plus 4, or 8. The next one measures an arc, so I'm going to skip that for now. Let's go on to CD. From C to D, that's 4. We know that. And the measure from G to D. G to D, that's here, that's 3. All right, the last two measure arcs. Let's take another look at these arcs. I know that these arcs are all going to be congruent to each other. In other words, T to S is going to be congruent to S to R, is going to be congruent to C to B, is going to be congruent to B to A, because they're all coming from congruent pieces of chords. So all of these green guys are congruent. Remember, I find arc measure by the central angle in degrees. The key word there being central. It has to come from the center. A lot of students see this 90 degree here and they say, oh, this is a 90 degree arc. However, this 90 degree is not on the center of the circle. We have to use this angle coming from the center here, which means I need to use this triangle to help me find this green angle, which will of course give me that arc. I'm going to draw that triangle again just so we can play with him and see him a little bit bigger. I have G and T and U. Again, that's this triangle here. I know that the hypotenuse is 5 and G to U is 3. I'm looking for this angle. Let's call him angle B, just for the sake of it. All right. That means if I use trigonometry, here's my angle. This side would be my opposite. This side would be my hypotenuse. And this side would be my adjacent. So looking at TOA, I have information about my adjacent and my hypotenuse. Adjacent and hypotenuse, I'm going to use cosine. Tangent and sine use opposite, and I'm going to try to use the adjacent in this problem. So I know the cosine of an angle equals the adjacent over the hypotenuse. So let's plug in what we know. The cosine of the angle, well, the angle is angle B. I don't know what it is. Or you could call it angle X if you want. The adjacent side is 3 and the hypotenuse is 5, so it equals 3 over 5. I want to get B by itself, that's what I'm solving for, so I need to get rid of cosine. So to get rid of cosine, we do the cosine inverse. That is what cancels out cosine. Of course, if I do it on the left, I have to do it on the right. So cosine and cosine inverse cancel each other out, and I get B by itself, which is what I want, equals the cosine inverse of 3/5. So I'm going to type this guy into my calculator, which means I'm typing second cosine to get that cosine inverse, and then 3 divided by 5. And that gives me 53.1 degrees. So that just gave me this angle. Again, this angle here is 53.1, which is the central angle making this arc. So all of these green arcs are 53.1 degrees because we already talked about how they are all congruent to each other. So let's see if that answered the question we needed. The arc from T to S is 53.1, and the arc from A to B is also 53.1. Perfect. All right. Last but not least, I have the fact that chords E and F to G, H are equidistant from the center. So that means that this line here is congruent to this line here. And if they're equidistant, that implies that there is a 90-degree angle. I measured distance, so it must be at a 90 degree. That means that these two chords are congruent. It says the radius of the circle is 15. And EF is 24. Let me write that EF part down. I know the length from E to F is 24, which means the length from G to H is also 24 because they have to be congruent. That means that these individual pieces are congruent to each other. So from E to R must be 12, and this must also be 12. So we can split this into their equal pieces there. Last, I know that the radius of this circle is 15. Be careful, we do not currently have a radius drawn there. If I draw in a radius, again, P to Q is not the radius because it doesn't go all the way to the edge of the circle. So if I wanted to create a radius, I could take advantage of this right angle here and create the radius from going to P to E. And then you've just created a right triangle. We know that that radius is 15 based on the instructions. So then to find PR, it's just this other leg of this triangle. If you draw that triangle again, just so we can play with it and see it a little bit easier, I have E, R, P. I know that E to R is 12, and I know that E to P is 15, and I just need to find R to P, and that will give me my first answer. So let's go ahead and use Pythagorean theorem again. C has to be the hypotenuse, so that means C has to be 15, and then B and A are interchangeable, just the other two numbers. 12 squared gives me 144. 15 squared, isn't that 225? Oops, 15 squared. Yeah, I want to make sure I got that right. 225, perfect. If I subtract 144 from both sides, 144, I get x squared equals 81, awesome. So then if I square root that, I know that x is 9. So the length from P to R must be 9. Finally, the length from G to H. G to H, oh, that's just this entire chord, 12 plus 12 or 24. Awesome.